Hi everyone, I am Kare, and today I'll be teaching you how to solve some SMO junior questions. And I will be teaching you how to solve algebra questions, which include Diophantine equations and how to solve roots. We'll first start off with Diophantine equations. So what exactly are they? When the question asks us to solve some Diophantine equations, we are supposed to solve for integer solutions for a set of equations where there are more than one variable. So for example, a simple one would be ax plus b1 equals to c. So to solve this Diophantine equation, we are supposed to solve for the sets of a, b, which fits the equation and are integers. And there are more complex types of Diophantine equations that we can solve, including the following. And it can also include infinity equations. Let's start off with an example of a Diophantine equation question. And we'll use SMO Junior 2009 question 20. So you can pause the video to do it first, and then we'll see how to answer it later on. From the equation in the question, we can simplify the equation into the following by factorizing it. And then as you can see, xy must be equal to 2009 because then the second term of this factorized equation then will be equal to 0. And only when xy is equal to 2009 this will happen because x and y must be integers. So from this, you can find out sets of x and y. Note that the numbers of x and y in the sets actually is reflected. So for example, the first one is 1, 2009, and the last one is 2009, 1. And this is because x and y are identical in the Diophantine equation. Thus, it shows some symmetry. And from here, you can find out that the number of ordered pairs is equal to 6. Next question is question 31 from SMO Junior 2012. Similarly, you can pause the video first and try out this question. This Diophantine equation can be simplified into the following by factorizing it once again. And you can see that 2013, we use prime factorization to separate the 2013 term into 3 times 11 times 61. And from here, there are 3 cases that we can consider. First is if all of x, y, and z are positive. If that is the case, none of the terms of x plus 1, y plus 1, or z plus 1 term will be equal to 1. And thus, these 3 terms will be equal to 3, 11, or 61 respectively in any order. So there will be 3 factorial solutions. Second case is if exactly one of them is 0. And there are 3 times 6 solutions because there are 3 is there because there are 3 possibilities of like the 0 occurring in the set x, y, and z. And then 6 is because the remaining 2 x, y, or z, there are 6 possible numbers, 6 possible sets for these numbers. So it adds up to 18 solutions. And the third case is if exactly 2 of the terms is 0. And if that's the case, 2 of them will be 0 and 1 of them will be 2013. So there will be 3 solutions. So if you add them up all together, the total number of solutions will be equal to 27. Now I'll be teaching you how to solve for roots in a typical SMO question. So what is very important for you to know, which is very basic, is the quadratic formula, which is if you want to solve roots with a known equation, and for the quadratic roots, you get the x equals to negative b plus minus square root b squared minus 4ac over 2a. Yes, you must remember this, it's very important. And then the second theorem is the Vieta's theorem. This theorem relates the sum of roots and the product of roots to any polynomial. But for now, you'll just consider quadratic equation. Yes, so the sum of roots will be equal to negative b over a, but the product of roots will be equal to c over a. It is quite important in SMO questions to know this Vieta's theorem because sometimes the questions will tell you something about the sum of roots and the product of roots, and you're supposed to find out what is the quadratic equation or something like that. Now we'll try another question, which is SMO Junior 2009 question 30. Well, this question uses both the concepts of Diophantine equations and solving for roots. So try out this question and you'll see how to solve it later on. So here's the solution. So you can use the quadratic equation to solve and simplify the value of x. And then from there, you realize that there is this square root term of square root n minus 45 square minus 2009. So you realize for x to be an integer, this square root value must be an integer. So m minus 45 square minus 2009 must be a perfect square, so that when you square root it, it can be an integer. So we let n minus 45 square minus 2009 equals to n square, when n is some integer. By rearranging the terms in the previous equation, we get n minus 45 square minus n square is equal to 2009. And then we prime factorize 2009 to form 7 squared times 41. And then we can use the difference of squares to get a more factorized form of this equation. And you realize that this is actually a Diophantine equation, which means that you can solve it normally because the product of two integers is equal to 2009, which is 7 squared times 41. So you use this to solve for m and n, ensuring that they are integers. And then solving for m is equal to 45 plus minus 1005, or 45 plus minus 147, or 45 plus minus 45. And from there, you realize that the smallest positive m is 90, and that is your answer. Thank you for watching this video, and all the best for SMO Junior this year.